Thank you so much. Great to be here. Kayrros is a digital MRV and environmental intelligence company. We basically use AI to process massive amounts of data from satellites, Earth observation satellites and other sources of input to generate signals, precise, actionable, trusted signals that can help market participants, industry participants, regulators, governments accelerate the decarbonization of the energy system and reduce our footprint and improve our climate balances. So we don't directly produce electricity, solar electricity, but we do monitor the development of solar capacity, particularly in the US in great detail. This is something that there's not much transparency about. Having the exact timing of the delivery of projects, there's many bottlenecks for many different reasons, is very valuable for gas and electricity traders and investors in the sector. But we have a great variety of data streams, and they fall into three main categories. So one is to manage the energy transition. One of our missions, and the data that we provide to support it, is to manage the transition itself, to monitor energy flows, to monitor the change in the fuel mix. And as I said, we monitor the deployment of solar capacity, but also wind capacity, battery storage, lithium mining, as well as fossil energy, crude oil inventories, crude oil refined product demand, like gasoline, diesel, jet fuel, marine bunkers, as well as LNG, liquefaction, shipping, and so on. Fracking in the US, shale gas and oil production. All these things are very important to manage a transition, to help integrate renewables into the grid and smooth out the disruptive effects of new capacity coming online. But our other mission is to protect people, assets, ecosystems by monitoring climate risks, such as the risks of wildfires and flooding. And the third bucket, and this is what I would like to speak most about today, is to help people reduce our greenhouse gas footprint. We do this by monitoring three main types of greenhouse gases variables: carbon emissions, methane emissions, and forestry carbon sinks, negative carbon emissions. Methane, why methane? Second largest source of global warming, 80 times the warming power of carbon in the first 20 years. The fastest rising source of greenhouse gas, responsible for 1/3 of global warming to date, responsible for half of global warming in the next 20 years on current trends, maybe even more. Yet at the time of the Paris Agreement, there was no methane target. Why no methane target? Why only focus on carbon? Because we knew about methane concentrations in the atmosphere. We knew about the risk of rising concentrations. We had no idea where the emissions were coming from. We had no idea about the sources of emissions, their rates, or anything like that that could enable action. That has changed, and I'm just back from COP28 in Dubai. Methane policy was front and center. A lot of initiatives were announced. A lot of this development of methane policies and strategies is really on the back of the new detection and measurement capacity that we've enabled, as well as some others in the industry. So you might have seen our map of super emitters. We measure basin-wide emissions from the oil and gas and coal sectors around the world, from wastelands, waste sites, landfills, from agricultural facilities as well. But here, this is a map of super emitters from the oil and gas sector. That's about 10% of emission. This is low-hanging fruit of climate action. You get rid of those, you slow down global warming by 0.2 degrees, and this can be achieved easily in a few years at a minimum cost. So critically important, we use several satellites to do this, and our business model is basically that we don't own satellites. We don't invest in the hardware. We don't have a footprint in space. What we do is that we use public data from public government-owned satellites that we get for free, and we provide tremendous processing capacity. We develop algorithms using wind dispersion models, weather data, all kinds of input, our database of millions of assets, and we translate detections of concentrations of methane, of plumes of methane that we can see from the sky, into actual detections of emission events with their rates, their sources, their timing, and all the information that we need to really reduce these emissions, abate methane emissions worldwide. So we combine the best of all kinds of satellites. All satellites have a trade-off between spatial resolution, temporal resolution, the frequency of revisit, and the sensitivity. You cannot optimize two of those variables and the third. There's always a trade-off between all these three. But by combining input from different sensors, we can actually achieve the best of all worlds and have a daily refresh of our detections and 20-meter resolution and sensitivity, which is 1 ton across the world, and sometimes as far as 0.1 ton per hour. So this has enabled a lot of policy development in the US. In the EU, we work very closely with the European Commission lately, with the European Parliament, with various governments in Europe to develop the regulations that were approved November 16. But we also can assess the impact of emissions around the world. And here, this is a map of the Permian Basin, the most prolific oil and gas basin in the world, which straddles the border between two states with different methane regulations. New Mexico, most stringent, Texas, less stringent. And we see that there's twice less production of oil and gas in New Mexico than in Texas, but 4 times less super emitters. So this is, everything else is equal, the geology is the same, the actors are the same. The only difference is policy, and policy is having an impact and is causing New Mexico to be half the methane intensity of Texas. Another policy impact, Turkmenistan, one of the largest emitters of methane in the world, just announced they would join the Global Methane Pledge and agreed to the US to work with them to reduce emissions. The Guardian newspaper reporting on our detections in that country was extremely instrumental in getting the US leverage in their negotiations with Ashgabat and in convincing Ashgabat to come to the table. Much of this information is now being used by the financial sector, and we're working closely with banks, BNP Paribas and others, in helping them incorporate these KPIs, these methane KPIs, into the decision-making processes, the decisions to grant loans, or the way they set their interest rates. And we've made this data in open access. We have an open access version of our website, of our map, where people can not only identify super emitters, but also track trade flows of natural gas and LNG in the world, and also the intensity of importers and exporters of natural gas. Carbon emission is another variable that we monitor closely, very different approach. Here, satellites are not there to provide information that was missing, that cannot be accessed through any other means. It really is there to provide more granularity, more frequency, more information that can help carbon markets become much more efficient and provide a much better service in driving emitters to reduce their footprint. We do this not by monitoring carbon emissions directly, but we track every activity that produces carbon. Transportation, both road, marine, and air, as well as power generation, energy, carbon-intensive industries like cement and steel. And we monitor their footprint every day, country by country, sector by sector, with great granularity. That's an indication of the demand for carbon credits in carbon-regulated markets like the EU, or California, or RGGI in the US. And a lot of carbon traders use our data to improve their strategies, and that provides much better signals. Finally, forestry, the third major leg of a carbon monitoring architecture. This is a market for carbon offsets, nature-based solutions that's undergoing tremendous crisis of confidence. There's been exposés in The Guardian earlier this year, in The New Yorker more recently, showing the huge scale of abuse, fraud, miscommunications, misinformation that's been going on in that sector, all because of opacity, a lack of transparency, because of antiquated inspection methods, in sending people with shotguns and tape measures to measure a few trees every 5 years. Completely changed. With satellites, we can monitor forestry worldwide at 10-meter resolution, and we can assess the height of the canopy, diversity of species, biodiversity, density of foliage, and the amount of carbon embedded in the forestry. We have years of history, so we can assess the additionality of new projects, and we can detect leakage, which is a key variable to assess the effectiveness of conservation or afforestation processes. So we work not just on our own, but we also partner with others. We've been partnering with a company called B0 Carbon, to help them certify. We provide the underlying measurements and observations that provide the basis for certification of forestry projects. But we also work with others like Bureau Veritas and Optel. We just announced last week at COP a partnership with them to help with the EUDR regulations, the new EU deforestation regulations. We help companies comply with these new regulations that come into effect next year. We provide the observation of the forestry. Optel provides the traceability expertise, and Bureau Veritas provides the certification. So that's a complete tool that helps companies prove that the commodities they import into the EU market have not been associated with deforestation since 2020. Thank you.